Multiple piping runs will often be run together in pipe racks, chases, trapeze hangers, or other means. They'll often need to offset together around obstructions. Often the design will require that the spread between the pipes be maintained throughout the offset, like the example on the left. This is referred to as a parallel equal spread offset, and it's the most desirable method, especially if the pipes are very tight to each other. Now another type of parallel offset is shown on the right, where the spread distance is allowed to change through the travel portion, then return to the original spread when it continues the straight runs. These are called parallel unequal spread offsets, and we will look at these types first in this short video. Here we have an example of an unequal spread offset, where you're asked to find dimension B, which is the length of the travel or hypotenuse, and dimension A, the reduced spread between the pipes. As we've mentioned before, the skill lies in creating or visualizing the usable right-angled triangles. The trick is sometimes relocating the given information. For this example, the distance of 5 inches would be the hypotenuse of this triangle, and there are a few different ways you could calculate the reduced spread for A. For angles other than 45 degrees, you would use trig, and your fitting angle would be the same as this angle here. This would become your reference angle because both of these imaginary lines are perpendicular to the piping. Therefore, the change in direction of this angle will be the same as your fitting. You'll see what I mean when we look at an example using elbows other than 45 degrees. As for pipe B, we're given the offset, which makes up one side of this triangle. And we can easily calculate the hypotenuse a number of ways, either with trig, Pythagoras, or we could use our constant of 1.414. Also, assuming we are to maintain the 5-inch spread when we finish the offset, then the travel length of the other pipe will also equal dimension B. Here's another example using 22.5 degree fittings. The imaginary right-angle triangle that you need to calculate the reduced spread is pretty much given to you. You'll be using trig to calculate dimension A. So the only real challenge is to make sure that you properly identify your reference angle. It is pretty obvious visually which one would be 22.5 degrees, but it may not always be so obvious. So notice that the angle that I have shown here uses the two sides that are both perpendicular to the two pipes, whereas the other acute angle uses only one side and the other is part of the imaginary triangle. To solve for A, we would just use our trig function of cosine, as we are given the hypotenuse and are trying to find the side adjacent. To get the length of our offset travel pieces, here's the triangle. And you can see that the 4-inch offset would be our side opposite, and we will be trying to find the hypotenuse. So we will be using the trig function for sine of 22.5 degrees. In the next video, we'll look at equal spread parallel offsets.